Hello, students. This is Dr. Faizan Mirza. In my this current video, I'll be discussing with you how dilutions are used to prepare a range of solutions using simple or proportional dilution method. Now, in simple or proportional dilution method, what do? We have a standard solution. For example, 1% of standard solution is provided to me, and using this solution, I'll prepare a range of solutions. I'm keeping all the volumes of my resulting diluted solutions as 10 cm cube. This is what I have standardized myself. To make these 10 cm cube of these solutions, what I'm doing, I'm adding enough of the solution to the diluent so that I have a standard solution diluted further. For example, 1% is diluted to 0.8%, and this 1% can be diluted to 0.6%, and this 1% can be diluted to 0.2%. How is this done? For example, if I have to dilute it 2.8%, what I'll do, I'll add 8 parts of the standard solution, and to this 8 parts, I'll add 2 parts of water. So 8 is to 2. So when I add 8 parts of the solution and 2 parts of water, I get 0.8% of my solution diluted. What I'll do, I have to make 0.6%. For the 0.6%, I'll add 6 cm cube of the solution into the beaker or into the test tube. And to this 6 cm cube, I'll add 4 parts or 4 cm cube of water, again to make a final solution of 10 cm cube. So first thing is to know what volume you need to prepare. So since I'm keeping all these 10 cm cube, the first I'm adding 8 and 2 together, then I'm adding 6 and 4 together to get 0.6%. And the last I'm taking 2 cm cube of this particular standard solution and adding 8 parts of water to dilute it to 0.8%. So this is how the range of solution can be prepared. Now let's take an example. So in this question, although I'm just taking it as an example here from 2018 begin 31, it was told to us that you are required to make simple proportional dilutions of proteins in the milk. M is the solution provided to us as a stock solution, and 1.0% is provided to us. So this is the percentage concentration of the solution, and this is given to us. Reduce the concentration by 0.2% between each successive dilution. You will need to make 0.1% concentration as well. Now they are asking you to how to carry this out. You will need to prepare 10 cm cube of concentration. So the volume is provided to you as well. What is given to us? I'll make a table of 3 columns. My first column will be a volume of M, or you can say milk. I'll mention the unit of cm cube, how much cm cube is to be added, volume of distilled water W again in cm cube, and the percentage concentration of the milk. If I add 10 parts of this and 0 parts of water, I get 1.0% concentrated M or milk solution, which is already provided to me. If I'm taking it as it is, if I take 1 part of this and 9 parts of the water, I get 0.1%. So this is provided to me. What I'll do, I'll dilute it accordingly. So if I add 8 parts of the milk to 2 parts, I get 0.8. If I add 6 parts to 4 parts of water, I get 0.6%. If I add 4 parts of this solution of M to 6 parts of water, 0.4. And if I add 2.0 and 8.0 together, I get 0.2. So this is how proportional dilution is done. Now in another question, this was given to us that how 10 cm cube of each concentration is prepared. I was provided here with 1.0 molar of mole per dm cube of HCl, and I'm given a table as well to fill this out. Final concentration, what I'll do again, I have 3 columns here, volume of the HCl, which I will be added, I'll be mentioning the concentration, and the cm cube or the volume of the HCl that I'm adding, volume of the distilled water and its unit, final concentration of HCl together with the unit of concentration or the unit of molarity here. 10 parts added with 0 water, 1.0%. Already this provided to not percent, 1.0 mole per dm cube. This is 1.0 mole per dm cube provided to me. I write it as it is using 0 distilled water and 10 cm cube of the solution. I'm told that I have to make 10 cm cube of each concentration. In next, I'll add 8 of this and 2 parts of this to get 0.8. Again, I'll add 6 and 4 parts to get 0.6%, 4 and 6 parts to make 0.4, and 2 and 8 to make 0.2. So that's how proportional dilution is done. So sometimes they give you percentage concentration, sometimes they give you mole per dm cube. So this is how basically it is to be carried out. Now, in paper 5, this question came in October, November 22, variant 53 of 51. And I'm just taking the example of the dilution, how dilutions are prepared here, not doing the whole question video. So the student was provided with a stock solution of this particular honey containing an NGO concentration of 600 micrograms per cm cube. So this concentration is provided to you. This was a clear solution labeled 100% honey. So this is representing 100%. This concentration is being represented as 100%. The same appetizer material was available. Describe how the student could prepare 10% solution of honey using the stock solution. So the stock solution is 100%. You have to dilute it to 10%. You have to construct a table and give a description here as well. So you will carry out proportional dilution here. So how proportional dilution is carried out? Again, what I'll do, space for table is provided for me. So I'll add 3 columns here. The first column will be honey, which is 100% honey, volume in cm cube, volume of distilled water that I'll add in cm cube, final percentage of the solution of this which we are preparing, and I'll mention its unit in percentage as well. So if I add 10 and 0, I get 100%. If I add 8 of this and 2 of this, I get 80%. If I add 6 of this and 4 of this, 60%. If I add them in 4 and 6, I get 40%. If I get 2 and 8, I get 20%. If I add 1 and 9, I get 10%. So this 10% is what's required. So this is the description that you will add here, that this is how the dilutions will be done. And using proportion dilution, you can prepare this very well. That's all from my side in this video. I'll be using another example in a separate video of how proportion dilution is carried out, because this needs more practice, similar to the serial dilution as well, of course. So that's it from my side. Thank you so much.